So in this problem, we've got Jamil. He's got 5 plums and 3 apricots in a box. And Rosa has X plums and 6 apricots in a box. 1 fruit is chosen at random from Jamil's box and 1 fruit is chosen from Rosa's box. And the probability that both of the fruits chosen are plums is 1/4. Now we've got to write down an equation in X and find out what X is. Now the probability of 2 events happening at the same time or in sequence is the product of the probability of those events. So for the first box, we've got 5 plums and 8 fruit altogether, so the probability is 5/8. In the second box, well, we don't know how many plums, but we know it's X, and so we can set it up like this, where X is the number of plums and X plus 6 is the total number of fruit. And see, now what we do is multiply the 2 fractions together, giving us 2 fractions that are equal to each other. And you know that we have 2 fractions equal to each other. All we've got to do is cross multiply in order to solve them. And we're going to end up getting 20x is equal to 8x plus 48, and x is going to equal 4. And that's all there is to that one. Let's go to the next one. Marianne has 7 sweets in a tin, 6 are toffees and 1 is chocolate. She chooses 1 sweet at random and takes it out. Her friend then adds 3 chocolates to the tin. Marianne takes another sweet at random of the tin. So we're supposed to draw a fully labeled tree diagram. The first choice is toffee or chocolate, and we've got 6 out of 7 and 1 out of 7. And then before the next pick, we're going to add 3 chocolates. So what's going to happen is that when I've taken 1 out, I'm going to only have 6, but now I'm going to have 9. So the toffee 1's been removed, so it'll be 5 ninths, and then chocolates will be 4 ninths. And then if I take out a chocolate, well, then it'll be 6 ninths for toffee and then 3 ninths for chocolate. And see, that's all there is for that. That's a fully labeled tree. Now, in part 2, we're supposed to find the probability the first sweet is a chocolate, given the second one's a toffee. So the probability of it being chocolate and then a toffee, well, that's going to be 1/7 times 6 ninths. And then the probability that it's a toffee, well, there's 2 ways that can happen. And that's going to be 1/7 times 6 ninths plus 6/7 times 5 ninths. And now all we've got to do is simplify the numerator and the denominator and figure out our answer is 1/6. All right, let's look at the next one. So Megan sends a message to her friends and she uses 3 different methods: text, email, and social media. For each message, the probability that she uses a text is 0.3 and the probability that she uses email is 0.2. So we can determine that the probability she uses social media, I'm going to use M, is going to be 0.5, and those are her only options. And now I know if her probability of getting a reply when she gets a text is going to be 0.4, and then the probability she gets a reply given that it was an email, well, that's going to be 0.15. And then the probability that she gets a response when it's social media is 0.6. Now, we're supposed to draw fully labeled tree diagrams for this information. The first choice is text, email, or social media, 0.3, 0.2, and then 0.5. And then the next choice is reply or no reply. And I'm just going to use a complement. And so we just fill in these probabilities as they're listed already here. And that gives us our tree diagram. And then the second part, it says, given that Megan does not receive an immediate reply to the message, find the probability that it was an email. So the probability it's an email, given that there's no reply. So the first thing is we've got to figure out what's the probability of sending an email and getting no reply. And then we're going to divide by the probability of getting no reply. So let's look here. That's going to be email 0.2 and no reply is 0.85. That's going to go on the top. And then we're going to take a look at all the other times when there doesn't get a reply. There's 3 of them. And they'll go on the denominator. And we have to add those together because we will accept any of those as no replies. And then all we've got to do now is simplify it. And I would suggest you use your calculator and the fraction ability of it and just type this all in. and then figure out what the answer is. And make sure if you do this that you double check everything. But in this case, we're going to find the answer is 17 over 55. Okay, let's look at the next one. Here we've got vehicles approaching a certain road junction from town A. They can either turn left, right, or go straight. Over time, it's been noted the vehicles approaching the particular junction at town A, 55 turn left, 15% turn right, and 30% go straight. So you'll notice how they sum up to 1, so that means these are the only possibilities for people to go. We've got 3 vehicles. 1 goes straight and the other 2 go left, or the other 2 go right. So one way that could happen is if the first one went straight and the other 2 went left, and we put those probabilities together. But the thing is, we've also got to consider all the different ways it can happen, the different sequence in which it happens. In this place, it's pretty clear. We could go left, straight, left, 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 straight. And then, of course, we have an or. We could also accept straight and right, right. And we can accept right, straight, right. And we can accept right, right, straight. So we figure out those probabilities, and we multiply those. Now, you'll notice that when we rearrange the letters, the probabilities all stay the same because the going right isn't different for any of the cases. So we just can multiply these by 3. And then we've got to add them together to get the total probability. And we're going to find out that the total probability for going straight and left, left, or right, right is 117 over 400, or 0.293. All right, now part 2 says 3 vehicles approach the junction from town A. Given that all 3 drivers choose the same direction, find the probability that they go straight. So now, the probability they all go straight, given they all go the same direction. Now, we've got to find first the probability that they all go straight and they all go the same direction. But this is nice because if they all go straight, they're obviously all going to be going the same direction. So all we got to do is figure out the probability for all straight. And then we're going to divide by all same direction. So that's going to be 0.33, and then that's going to be 0.55 times 0.55 times 0.55. And then if they all go the other direction, which is right, that's 0.15, and then we multiply those. And so really these are all to the 3rd powers. We could have written it like this. It'd probably been a little bit easier. But anyway, all we've got to do now is simplify it and figure out what our answer is. And I would suggest again that you just do most of the work in the calculator. Let it do all the calculations. Just be careful that you're entering in the numbers accurately, and that way you'll get the right answer. So anyway, when we do this, we're going to find out that the answer is going to be 108 over 787. All right, let's take a look at the next one. In number 5, we've got a group of students, 3/4 are male, and the proportion of students who like their curry hot is 3/5. In this case, they're giving us all probabilities. And I mentioned in class that you could, when I first looked at this, that I just figured out a number of people and then worked it out that way. If we're just going to use the probabilities, well, the first question says find the probability that the student chosen is either female or likes it hot, or is both female and likes it hot. So if I'm going to add these together, first female, and then if I find the probability of them liking it hot, well, that's the male times their percentage that likes it hot, plus the female, which is 1/4, and the percent of them that like it hot. But then I'm going to take away the overlap. And the overlap in this case is going to be the females that also like it hot. And so that's 1/4 times 4/5. You'll notice that these last two just offset each other, and that we really just needed to do the males and then the males that like it hot. Because what happens in this case, when we're looking at the females, we actually picked all the females, whether they like it hot or not. Another way to look at this would be to think about them just like that. if I pick the females, well, I've got all the females that like it hot already, so I don't have to worry about that. And then when I'm looking at the curry, I don't need to think about the females because I've already found all the females. All I need to worry about is the males that like it hot. And so again, that's just going to be 1/4 times 9/20, and that's going to give us 7/10 as our answer. Now, it says show your work. Determine whether the events a student chosen as male and the student chosen likes their curry hot are independent. So first, all we got to do is find whether or not these individual probabilities, and then find out if I multiply them together, if it really does equal when they happen at the same time. So the probability of A, that's a student is male, well, that's easy, that's 3/4. And the probability the student likes it hot, well, we did that over here in the other problem, that's 3/4 times 5/5 plus 1/4 times 4/5. So we figure that out, that's 13/20. Now what I've got to do then is take a look at the probability that they want, or that they are a male and like it hot. And that probability is 9/20. And so when I multiply these together, the question is, will I actually get 9/20? And in this case, you can see that we don't. So these events are not independent. Where some people get confused by this is how they do find the probability of A, and they find the probability of B, and then they multiply them together, and then they say, well, of course it equals the probability of A and B. And the trick is you have to figure out the probability of A and B a different way than multiplying A times B. In this case, you notice we just used the males and times the percent that wanted it hot. Anyway, let's go on to the next one. In number 6, we've got a group of students, boys and girls, and they study art, music, and drama. When you're given a table like this, they haven't already, I think it's a good idea to put the totals in, especially if they're asking more than one question. And the first one they want to know is find the probability the random chosen student studies music. Well, that means boys or girls. That's going to be 52 out of 160. And if you're wondering if you've got to show a lot of work for that, no, not when you're given a table like this. You just want to reduce it. And then in number 2, determine whether the events a randomly chosen boy and a randomly chosen student studies music are independent. So if it's a boy, that's 96 out of 160. And if they study music, that's 52 out of 160. Now, you take a look at the table. If it's a boy and music, that's going to be 40 out of 160. So the question is, does 96 over 160 times 52 over 160 equal 40 over 160? And the answer is no, it doesn't. And so these events are not going to be dependent or not be independent. Now, in the third one, it says find the probability that a random chosen student is not studying drama given the student is a girl. So I write this as a conditional probability. They're not studying drama given they're a girl, so I need to find the girls that are not studying drama. Well, that's going to be 60. No, that's going to be 27. 27 out of the 160. And then I've got to find the girls, the probability of being a girl. Well, that's 64 out of 160, giving me 27 over 64. Now, you don't have to use a formula. When you're given a table like this, you can just say, hey, here are the girls. I'm only going to look at the girls. So that's going to be 27 out of 64. In part 4, 3 students are chosen at random. Find the probability that exactly 1 studies music and exactly 2 are boys. All right, so keep in mind, it seems like we're doing one thing, but whenever you are, we have 3 things, 3 elements. We've got to multiply the probabilities together. You've got to consider the different sequences in which they could possibly happen, even though it doesn't seem like it's a sequential kind of a thing. So what we'll do first is we'll say 3 students are chosen at random. Imagine that we're picking one and then picking another and then picking a third. So what I want to know is find the probability that 1 studies music and 2 are boys. All right, so let's kind of lay this out. Let's figure out one scenario that'll work. One would be it's a music and a girl. Okay, that's one way. And then that means that the other 2 is going to be not music and a boy and not music and a boy. All right, so to find the probabilities, all I've got to do is take a look at my table here. And music and a girl, well, that's 12 out of 160. And not music and a boy, that's going to be 56 out of 160. And then not music and a boy, well, now we've taken away open. And see, I forgot, we've taken away one person each time, so these we have to reduce 159 and then 158. And see, the thing is, now I've got to ask myself, well, there's different sequences I can do this. I can take these three things and rearrange them, and you'll notice that there's just going to be three ways that that could happen. And so these probabilities themselves will stay the same. They're just going to get rearranged. So I'm just going to multiply this times 3, and that will give me the probability. I know it seems weird. Why do I have to multiply it by 3? Whenever more than one thing are happening, think of it as happening one and then another and another. The sequence has to be taken into account. Another thing is, now that we've talked about factorials, another way to look at it would be 3 factorial over 2 factorial, because two of them are identical. Now, there's more, because that's not the only way we can satisfy this requirement. I could have a music and a boy, and then not music and a boy, and not music and a girl. So I got to figure out the probability for those things happening. Now the difference is, in this case, you'll notice how I've got 3 things, but they're all unique. So how many different ways can I arrange 3 things? Well, that's going to be 3 factorial. I'm not going to write all those out, but I could have rearranged these 6 different ways. So I'm going to take these probabilities that I've got written over here, and I'm going to multiply them by 6. And then after I do this multiplication, and then I'm going to take these 2 probabilities, and then I'm going to add them up, and that's going to give me the total probability for the answer to number 4. All right, that gives me 0.201. Let's look at the next one. In number 7, we've got a probability tree. It's partially made. They give us information that looks like it's all pretty much in the table already. And then what we're going to do is find the missing x. If we take a look at what they're telling us that the probability of being an advanced swimmer is the same as the probability of being a beginner. So all we've got to do is fill in the information that they kind of left off on our table. If the one side is x, the other side is going to be 1 minus x. And then what we're going to do is create this equation as if I was finding the probabilities of advanced swimmers and making it equal to the probability of the beginner swimmers. And you'll notice I've got a big old fatty waddy equation, but there's only x's in there. And once I simplify it, all I've got to do is get the x's by themselves, and I'll know what x is equal to. And that will be awesome. So in this case, I've got 0.55 minus 0.25x, and it's going to equal 0.45 plus 0.25x. When I simplify it, it's going to be 0.10 equals 0.5x. X is going to equal 0.2. So now I know that's 0.2, which means this other side's got to be 0.8. And I can fill that in. And are there more questions here? Oh, yeah, there are. Part 2. Given that a randomly chosen member is an advanced, find the probability they're male. So the first thing is we need to find a male that's advanced. Well, that's going to be 0.2 times 0.3. And then we've got to find any advanced. Well, that's the male and then the female advanced. And so then we divide those and we find out the probability is 0.12 or 3 over 20. In this problem, like I said in class, ignore the first part of the problem. I've changed it, so this is actually just the second part, even though it's labeled number 1. Find the probability that Jake will complete the puzzle in at least one of the 2 days, Monday and Tuesday. So what we're talking about is complete, and not complete, or not complete and then complete. Those are the 3 possibilities. So now the probability of it being complete and complete, well, that's going to be 0.8 and then times 0.9. That's giving me 0.72. And then complete and then not complete, well, that's going to be 0.8 times 0.1. And then not complete, well, that's 0.2, and then complete's 0.6. And then all I've got to do is add these probabilities together, and I get my answer of 0.92. The other way to look at this is go away 1 minus the probability of not completing it 2 days in a row, and then I'll be able to figure out the same thing as completing it at least once. All right, that's 0.92. Let's go on to the next one. In number 9, we've got another probability tree. They've kind of set it up for us, but not really. We got to fill in the probabilities. We've got 3 red balls and 5 blue balls. We got to label these parts, put in the probabilities. Now we're going to add 1 yellow. That seems kind of weird, but that's why there's 3 choices now: red, blue, and yellow. Red, blue, and yellow. And then we fill in the probabilities. Well, there's still going to be 8 because we took out 1 and put 1 back in. So now we just got to take into account the adding of the yellow marble. And we've got new probabilities, and there is our tree. Now find the probabilities that the 2 balls taken are the same. Well, there's only 1 yellow one, so that's not possible, but there could be 2 reds and there could be 2 blues. So all we do is multiply those and then add them up, and we're going to get 3 over 32 for the 2 reds, and then for the 2 blues, well, we're going to get 20 over 64, which reduces to 10 over 32, and then we add them together. All right. So find the probability that the first ball taken is red given the second ball is blue. Well, first thing, we find the red and blue. Well, that's going to be 3/8 times 5/8. And then we just got to see the probabilities where we ended with a blue. And that gives us these. And then see, we just got to simplify that by dividing. And we're going to find our answer is 3/7. Let's go on. In the last one, we've got a fair-sided die. We throw it twice, and the scores are noted. X is the event that the total of the 2 scores is 4, and the event Y is that the first score is a 2 or a 5. Now, let's go ahead and lay this out. You could possibly anticipate this. There aren't that many ways to get 2 rolls and get a 4. 1, 3, 2, 2, and 3, 1. The problem is if you don't fill it all out on the table, you might miss the 3, 1. And then the other possibilities of starting with a 2, that's pretty easy to predict. I don't need to fill out a table for that. And I almost missed one, though. And then 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. In this case, I probably could write the possibilities without filling out a table, but it's a pretty good idea to do that anyway. And so this is a table when I have two of them, and you can see we've got these choices here, and there are the 3. That's the only ones that equal 4. And of course you can see the other ones. They match up. And now what we've got to do is find the probability of X. Well, that's going to be 3 out of 36. And the probability of Y, that's going to be 12 out of 36. And see, now we're going to multiply those together, but then we need to find out if it equals, well, where the overlap is. And you'll notice looking at the table over here on the right, there's only one time where it meets both criteria of X and Y. The 2, 2 is both 4 and starting with a 2. So when I multiply those together, it does equal 1/36. These are independent events. You can tell it's going to work because I'm going to get a 36 over 36 times 36. So that's going to end up being 1 over 36. 1 over 36 does equal 1 over 36. So that means that these guys are independent. All right, awesome. Thanks for watching. Hope that helped.